Here is the video of the ASE 2024 tool demonstrations track LLM4Workflow. Currently, workflows are pervasive in software systems where business processes and scientific methods are implemented as workflow models to achieve automated process execution. At present, most workflow tools require users to design workflows either using a low-code approach via script languages or no-code approach via visual editors. Despite the benefit of no-code or low-code workflow automation, creating workflow models requires in-depth domain knowledge and non-trivial workflow modeling skills. Recently, the potential of using large language models to assist in workflow automation has been explored. This table compares LLM4Workflow with the most relevant LLM-based workflow tools. It can be seen that our tool has more comprehensive advantage in workflow modeling. LLM4Workflow is based on large language model and the rewrite-retrieve-read retrieval-augmented framework. The process of LLM4Workflow comprises four main stages. Stage 1, one-time API knowledge base preparation. Stage 2, task extraction and rewriting. Stage 3, API retrieval. And Stage 4, workflow model generation. Next, I will use a case study combined with a video demonstration to present the entire process of generating a workflow model using LLM4Workflow. We take the climate dataset MergeVis workflow as an example, which formats future climate data to be consistent with historical data. This workflow is derived from ecological niche modeling within the Kepler Scientific Workflow System. You can access the workflow using the link provided above the video. Stage 1 is one-time API knowledge base preparation. There are a lot of public APIs available on the internet, but the format and quality of API documentation are inconsistent. While it is possible to use these API documentations directly by LLMs, it can lead to low-quality workflow generation and failed workflow execution later. Therefore, it is important for users to pre-build API knowledge bases targeted to their own specific requirements before the use of LLM4Workflow. The API knowledge base only needs to be built once, and then it can be updated with new APIs on demand. Stage 2 is task extraction and rewriting. LLM4Workflow executes the rewrite step of the rewrite-retrieve-read framework. Workflows are typically represented using directed acyclic graphs, where each node represents a task and each directed edge represents a dependency between tasks. Therefore, our primary goal is to extract a structured task sequence from the user's unstructured workflow description. To enhance retrieval quality and generate accurate workflow models, we rewrite the extracted task sequence into optimized queries. Stage 3 is API retrieval. In this stage, LLM4Workflow executes the retrieve step of the rewrite-retrieve-read framework. LLM4Workflow traverses the optimized queries and performs the maximal marginal relevance search in the vector database. After traversal, the results are merged and deduplicated. We can manually remove irrelevant API and customize relevant API that were not retrieved. Stage 4 is workflow model generation. In this stage, LLM4Workflow executes the read step of the rewrite-retrieve-read framework. The extracted task sequence and the retrieved API are embedded into the LLM's context. LLM then analyzes the task API matching relationships as well as the task dependencies and eventually outputs the workflow DAG. We further convert the workflow DAG model into XML format, which is ready to be executed by real-world workflow systems. We demonstrate the effectiveness of workflow models generated by LLM4Workflow in Edge Workflow, a real-world platform for edge computing-based workflow applications. After clicking Copy Code, we saved the workflow model XML file locally, specifying simulated execution times for each task. Next, we imported it into the Edge workflow system, configured the Edge computing environment, and set up optimization algorithms to instantiate the workflow. Finally, by clicking the Execute button, we obtained detailed execution results for the workflow instance. That's all. Thank you.